So let's go ahead and pump this idea up a notch. As you look at part D, we have 5 to a power is equal to 125 to a power. Again, in order to use our property from the top of the page, we have to have the same base on the left-hand side and the right-hand side. So I have the choice of using a base of 5 or a base of 125. It's a lot easier to use the base of 5 because I already know a way of rewriting 125 in terms of that base. So left-hand side, I'm just going to leave it alone. We're going to have 5 to the x squared plus 8 power. And on the right-hand side, I know that 125, just that piece, is 5 to the third power. Well, that 125, though, was taken to the 2x power. So this 5 to the third also needs to be taken to that 2x power. So now that I have this, I have 5 to a power, and that whole thing is to another power. Thinking back to the rules of exponents that I gave you at the top of the page, remember that if you have 5 to a power and that whole thing is taken to another power, you're going to multiply the exponents. So our left-hand side then is still 5 to the x squared plus 8, but our right-hand side becomes 5 to the 6x power. Now that I look at this, I have the same base on the left-hand side and the right-hand side. So the property from above is going to kick in. 5 to a power equals 5 to a power. The only way that that can be true is if the exponent on the left is equal to the exponent on the right. So x squared plus 8 has to equal 6x. Now that I have that then, this is a quadratic equation. I can solve quadratic equations using all of those techniques we've talked about earlier in the course. I can use the zero factor property, I can use the quadratic formula, I can use completing the square. All of those things are still available to me. Now I'm going to see if I can use the zero factor property. So once again, the zero factor property tells me the first thing I should do is get a 0. So I'm going to subtract 6x from both sides. And then if this happens to be factorable, I'm going to move forward. And on this problem, it does happen to be factorable over the integers. So I'm going to do the factoring. I need to find two numbers that multiply together to give me that positive 8 and add together to give me that negative 6. Looks like a negative 4 and a negative 2 will accomplish that. So I'm going to have a factor of x minus 4 and a factor of x minus 2. Set each one of those equal to 0. We get x minus 4 is equal to 0 or x minus 2 is equal to 0. Solve each one of those equations. We get x is equal to 4 or x is equal to 2. So now something nice to notice about this particular problem is that we ended up with two different solutions, a little bit different than what we saw in A through C. So x equals 4 or x equals 2. Now that we're set with that one, we're ready to move on to part E. Now remember once again from the property at the top of the page, we have to have the same base on the left-hand side and the right-hand side. But there's another detail you need to be aware of in terms of that property. Not only do I have to have the same base, I can only have one copy of that base on the left-hand side and the right-hand side. So when I look at part E, I notice that on the left-hand side I have a base of E, and on the right-hand side I have a base of B. But on the left-hand side I have too many E's. I have e to a power, and then I have another e to a power, all happening on the left-hand side. So when I see a problem like this where I have too many e's, my first step is to try to figure out some way of getting the left-hand side so that I only have one version of that e on the left-hand side. So I don't want to have two different e's on the left. I want e to a power on the left-hand side where I only see that e one time. So how am I going to do that? Again, it's going back and using some rules of exponents. So let's see what we can do in terms of our rules of exponents. So on the first spot, I have e to a power to another power. We already talked about that a moment ago. That's going to be a multiplication of the exponents. This is e to the 4x power. So we have e to the 4x power times e to the x squared is equal to e to the 12th. Well, once again, I have too many e's on that left-hand side. I have e to a power times e to a power. I only want one copy of that e on the left-hand side. So what I need to do is once again use a rule of exponents to help me out here. Now sometimes when people look at this problem and they see that e running around, they get a little scared about that e and they forget about some things that they already know about. So if I gave you a problem like y to the 7th times y to the 3rd, most of you would look at this and say, oh, that's y to a power times y to a power. We have an exponent rule that says we're going to add those exponents. So we're going to have 7 plus 3 power, and that's y to the 10th. Well, in fact, we can do exactly the same thing with this e to a power times e to a power part as well. We have a lovely power rule that says if you have e to a power times e to a power, you can add those exponents. So this is e to the 4x plus x squared power. But 4x plus x squared, if you think about that in terms of polynomial ideas, we've seen the idea of descending order, which means you start with the highest power. I'm going to go ahead and do two things at once. I'm going to go ahead and write this as x squared plus 4x, and I'm using that idea of adding my exponents, but I'm also using the idea of writing this in descending order. So it's e to the x squared plus 4x power, and this is equal to e to the 12th. Well, now that I have this, base on the left is e, base on the right on the e, and again, I only have one copy of e on both the left and the right. So the property from the top of the page now does apply. So e to a power equaling e to the power, the only way that that can be true is if the exponents are equal. So x squared plus 4x from the left-hand side is equal to 12 on the right-hand side. Once again, that's a quadratic equation, and I'm going to see if the zero factor property will help me. I'm going to subtract 12 from both sides. X squared plus 4x minus 12 is equal to 0. Find two numbers that multiply together give you the negative 12, add together to give you the positive 4. I can do that. We have x plus 6 and x minus 2 as our factors. Set each one of those factors equal to 0 and solve. We get x is equal to negative 6 or x is equal to positive 2. And as you look at this, notice once again, we ended up with two different x values for this particular problem. At this point, you are ready to go ahead and check out the homework associated with this section.